Now let's look at a couple examples dealing with parallel and perpendicular lines. Starting with this one. This one is looking for an equation that is going to be perpendicular to 7x plus 4y equals 85 and passing through the ordered pair 7, negative 5. Now, if you click View an Example in My Math Lab, they're going to take this guy, solve it for y to find the slope, find the perpendicular slope, and you're going to have fractions all over the place. But there's a little trick here. In order to find an equation that's perpendicular to another one and it's in standard form, here's what you can do. Take these coefficients and crisscross them. So that would make this now 4x and 7y. Notice I don't have any signs here just yet. We're going to get to that. So remember, for perpendicular lines, their slopes are going to be negative reciprocals of each other. That means that by crisscrossing these, I'm accomplishing the reciprocal part of the negative reciprocal. To get the negative part, we need to change one of these signs. Not both, just one. These guys are both positive, so when I crisscross them right now, they're still both positive. But I need to change the sign of one of them. And I'm going to choose to change the sign here to make that a minus. I could have made this guy negative and that would have kept the 7 positive, but by making the 4 negative, that would have meant that in my standard form I'm leading with a negative term. Alright, so now I claim that these two pieces right here would have slopes that are negative reciprocals of each other. We just need to figure out what goes over here. Well, I'm going to tell you right now that this 85 doesn't mean anything. He's not used at all. What we're going to do is we're going to use the ordered pair that we were given right here, and we're going to plug them in for x and y in our new equation. So, in our little thought bubble, that's going to be 4 times 7 minus 7 times negative 5. You work this out, and that's what that number is going to be right there. Alright, so we have 28 plus 35, and that gives us 63. So that's the number that has to go here. You might say, how do you know it's 63? How do you know this is going to work? Well, that's because this ordered pair is supposed to be a solution to whatever line we come up with, whatever equation we find. And if you plug in 7, negative 5, you get 63. So it will be a solution here. And so it's kind of weird that we didn't know what that number was. But by plugging in the ordered pair, it kind of forces your hand, and it tells you exactly what it has to be. And there you go. So that's it. Nice and easy. Now, if you were to take this equation right here and you solved it for y, think about what would happen here. To solve for y, you'd have to first subtract 7x, and then you would have to divide by 4. And I don't really care what that constant is. It doesn't really matter. What I want you to see is that the slope here would be negative 7 over 4. For this line that we're claiming to be perpendicular to the other one, if you solve this for y, that means you would have to subtract 4x first, then divide by that coefficient. Well, these two negatives would reduce away, leading us to a slope that's a positive 4 over 7. And so you can see that between these two guys, their slopes are negative reciprocals. So that's a really cheap, easy way, if you have something that's in standard form, to make it perpendicular. Take these coefficients, crisscross them, and change one of their signs. Alright, let's look at this one. You need to be parallel to this equation, but then passing through the ordered pair 7, 4. Alright, well, here's something that I know already. Parallel lines have the same slope. So I could go ahead and write this. I could say that y equals 2/9 x plus something, right? Now I know, here's something I know that it's not. I know that it can't be the 7. And in fact, the 7 doesn't really do anything for us, okay? It's really just there to say, well, you can't be 7, you have to be something else. Well, to figure out what that something else is, we've got a couple of options. You can plug in the 7 for x and the 4 for y, and then solve this. Like, go ahead and write the letter b there and solve that. Or we could do a little trickeration. And what I mean by that is that we can go ahead and put this in standard form if you don't want to have to deal with fractions. Because if I were to plug 7 in right here, the 7 and the 9 won't reduce, so I will have to deal with fractions. So let me avoid that and do this. Just like we've shown, let's move all of the variables together onto the same side. So we now have negative 2/9 x plus y equals something. Well, two things are wrong here. We're not supposed to have fractions and we're not supposed to have a negative. So let's get rid of the negative first. And we can easily do that by multiplying both sides of the equation times a negative, which now makes this positive 2/9 x minus y equals something. Again, I'm going to get to that. So we took care of the negative, now let's take care of the fraction. If we multiply everything times that denominator, we can clear out that fraction, and the rest of the way is going to be super easy for us. So these guys reduce. We have 2x minus 9y equals blank. And the blank that we're going to fill in here is very similar to the blank that we filled in right here, where we filled it in, we found the 63. Just by plugging in the ordered pair that was going to be a solution to that line. We're going to do the same thing. So my ordered pair is 7, 4. So when I plug that in, plug in 7 for x, plug in 4 for y, 14 minus 36 is negative 22. So it forces the hand for this equation, and it tells us exactly what that constant is. And this is an equation that's going to be parallel to that guy. Now, if you see something like this in my math lab, and you've done it this way, but it's asking you to put this in slope-intercept form, it's not a problem. To put it in slope-intercept form, just come over here to the side and solve this for y. You've probably done a lot of this by now, so it shouldn't take you too long. So first, we move the 2x to the other side by subtracting it, and that's a negative 22 that's already over there. Divide everything by negative 9. Let's see what we have. So we get y is equal to negative divided by negative is a positive, so positive 2/9 x. Negative divided by negative makes that a positive 22 over 9. So if you were doing a test for me, either of these answers is perfectly fine, because I don't care if it's in slope-intercept form or standard form. It just has to be one of those. But in my math, I'll make sure that you read and pay attention. When you compare this equation to the one that we were given, notice how the slopes are exactly the same, 2 over 9. But your y-intercepts are going to be different, because if they were the same, then you would have the same line, and they wouldn't be parallel.